Hi. In this video, we will create a temperature sensor management. First part, create a program. I'll name it Temp Sensor Management. Then we declare our variables. We have temp value as real for the analog input reading, temp out as real for our temperature output, alarm detector as alarms detect function block, alarm active as bool for the sensor alarm status, and finally alarm ID as UINT for the alarm identification. Okay, in the logic we're going to code, we're going to use the limit function from the library tree to protect downstream displays and communication. The limit function is used to protect the system from invalid sensor readings. Even if the sensor fails or sends incorrect data, the displayed or communicated value will stay inside a safe range. Here we limit temp value between -30 and 130. IN is the input value. MN is the minimum allowed value. MX is the maximum allowed value. If the temperature goes below -30, the output will stay at -30. If it goes above 130, the output will stay at 130. Otherwise, it passes the real value. This ensures stable and safe temperature communication. Now let's talk about the alarm detection logic. Inside the alarms detect function block, we define the alarm condition. The alarm condition becomes true if the temperature is greater than 130 degrees or lower than -30 degrees. This ensures we detect abnormal sensor values. If the condition is true, the alarm block activates. The alarm ID is passed to the function block. This alarm ID allows the system to properly identify which alarm is generated. The output X alarm status is connected to alarm active. So when the condition is detected, alarm active becomes true. This is important for monitoring and diagnostics. So in summary, the alarms detect function block checks for extreme values, above 130 or below -30. The limit function keeps the usable temperature between min and max value degrees. This structure ensures alarm detection for abnormal conditions, safe scaling of the sensor value, and clean output for display or communication. Now, Let's move to the live debug to better understand how the program works. First, we connect the virtual variables to the physical ones, and then we start the simulation environment. Once the simulation is running, we activate the live debug mode. This allows us to monitor the variables in real time. We can observe how the values change during execution. By doing this, we clearly see how the control logic responds. This step helps us verify that the program is working correctly.